Good afternoon, everyone. Hopefully you're all good. I should have shared the live stream link in the description in our Discord. Let me just grab the chat. We'll see how we do today, eh? It is very hot today. So yeah, we're gonna take it a bit chill. Right. Okay. So, well, off stream, I've been talking to people in the Discord about how to fix this particular issue. We still have this issue where we do a pop and swap on a buffer and we get weird results. So we get like an extra yellow over there and a red sphere gets deleted. The rest get deleted fine. It then crashes when you do that. I haven't solved this. I haven't really cared about this issue, so it's likely Total Colliders doesn't meet the. Yeah, this is actually this is actually real busted. Actually, yeah. So I'll fix this. This is like an easy one to fix. Yeah. So I hope everyone's doing well today. Hopefully it's not as sweaty where you are. I've got the fan going, so hopefully that's not coming through on the mic. So yeah, let's fix this like simple issue, right? So the reason, actually, I'll explain a little bit better what we're trying to achieve here. So let's just imagine for a minute, like I don't know, we're collecting these spheres, right? And for some reason the player goes for the blue sphere first, because that's the rule of the game, and they go into it and they collect their blue sphere, right? It should disappear, but we shouldn't then get a yellow sphere over here. This is just a standard mechanic in most 3D games that once you interact with an object or pick something up or kill an object or whatever, that you should be able to remove it from the scene so the player doesn't, you know, try and pick up the same thing twice or whatever. And this needs to happen arbitrarily at any point in, like, let's just say we've got, I don't know, all these things are collectibles, for example. You know, the player needs to be able to collect this one and then this one, not in order. Unfortunately, right now this only happens backwards, so we can only delete stuff from the array backwards. Now, I have been learning about buffers off stream, but I'm still not convinced that I need to create 3 buffers. Yo, good afternoon, dude. How you doing, dude? So I'm not quite convinced that we need to delete 3 buffers. Sorry, we need to create 3 buffers. But yeah, we're going to try that. The first thing that we're going to do is fix this collider equals 4 issue. Hello world, hello Jackie. How you doing, guys? Hopefully you had a great weekend. I know I couldn't stream on Sunday, but that's often the hardest day for me to stream. Hopefully you guys had a fantastic weekend afterwards. Yeah, so we have this like variable, which I think is pretty straightforward to fix. We actually just need to do the size of the buffers that we're accessing. I think that's a pretty straightforward fix. We can fix the crash on close, but which is like trivial. Yeah, so Total Colliders is complete nonsense. If we're deleting all the entities and they all have bodies, then this is simply just a variable that needs to be changed, and we can then delete all the elements and close the thing without it crashing. Although it wouldn't really matter in a release build, but you know, you don't want to. Let's just delete everything. That yellow one's the last one to be deleted, and then we close, and then okay. So yeah, that's a simple fix. But yeah, that is not the issue we're after. Please add caption. Please add caption. What you add, like subtitles? Like live subtitles, like something that subtitles my voice. I wouldn't know how to do that. Despite I don't know how many streams now, maybe 70. Yeah, I would like to. Is there a way to do that? Yeah, I'll look into it. I'll look into it. Let me write that down. If people are interested in that kind of thing, I could do like a, look into. The other thing I need to look into, honestly, is adding a bot or whatever. And close captions. Yeah, because I would like to make it clear, because sometimes it's not always clear. I'll try and figure if that's something that might be good. It might not necessarily be something I end up doing, just for the fact that I might cover up some code or something like that. But I'll look into it. I'll see what we can do. Yeah, let me turn the music down. I feel like that's a bit loud at the moment. Yeah, it's a bit loud. There we go. I think that's part of the problem. Okay. Do you go live for 5 hours? I just go live until about 5 o'clock, something like that. So I don't stream for 5 hours, but I go to about 2 to 5. So it's about 3-ish to 2.5, 2 hours, around that long. That's how long I go for. And I typically try to do it consistently, so I keep up making progress. Right. Okay. So let's dig into this. So I want to explain this a little bit more, just so I can air out what I understand and what I don't understand. So we have a buffer, right, that we have to upload data to. And the problem may be a race condition, or we're trying to delete stuff that's already on the GPU. So we get some corruption and values that shouldn't exist. So the first thing is a data race, and I try to eliminate this by having a delete command at the beginning of the frame. So if you imagine a buffer, right, a buffer can just have arbitrary data in it. I don't know. You can think of it as maybe easier with Paint, right? Because I know not everyone's like at this, super familiar with stuff. So let's create a white rectangle, and we have a command here, and then another command here, and then we have 2 buffers, which will be red. So, oops, let's not do that. Let's change this to white again. And so this is the CPU. Where's the paintbrush? So this is the CPU. This is the GPU. Right. And hopefully I can change colors without breaking everything. Let's go on this, go red. And then we have a buffer here, right? And let's do solid fill red. Right, okay, so what ends up happening, if we go back to see this, go to yellow, go to white. We write to this buffer, right? And it's possible that the GPU is already trying to read from it. So let's just say it's like, I don't know, like the GPU is like here in the buffer, and it's going from left to right. So it's going this way, right? Down the stream, right? And all I do is then I just change it to, I don't know. Let's just say I change it to something like, where's the fill tool? Like I change the whole thing green. Like this breaks because we're not actually finished reading, so we have a data race. So what you actually need to do is have 2 buffers. So if I go to here, change this to red, so we have another buffer here. So, and then we read here, let's go to paintbrush. We read this guy. Oops, let's change this to white. This guy, right? So the GPU is reading this buffer. It can go from start to finish, pretty straightforward like this. And we can write on this buffer, and we can change this green. I don't know, green is like updated, and this is like reading. Now, what we need to do after that is we need to swap the, once this is finished and once that's finished, so let's say this is complete as well, then we need to swap the arrows around. So afterwards, we would take this and we go, okay, paintbrush, like this, we go here, and then this goes here, and these are now red again, right? Because they are being red, oops, and like this. But at this point, right, we can, I don't know, get rid of these. Like these don't exist anymore. Let's go a bit bigger. Right, these don't exist. These are, oops, wrong way around. So this one doesn't exist, and then this one doesn't exist. So this is the idea, right? We swap the pointers that are reading the buffers. So that was after a frame is complete, and then the GPU reads again from the top buffer, like this, and vice versa, right? Okay, so that's the idea, right? I don't think I actually need to do that. Hopefully that was a so yeah, yeah, I'm glad you like that. So yeah, once we finish, then yeah, it'll go green again, and then we swap the arrows around. So that is what that's what I don't think I need to do. So that is what I've been told to do, but for this particular type of buffer, it applies to every single frame. So the first thing I'm going to do is simplify my render a little bit. And reduce the frames in flight. So we have 3 frames in flight. What does that mean? So on the GPU, we record the commands that need to run on the GPU from top to bottom. So the first one will be clear the screen. The second one will be resize, deal with the resizing. Third will be draw, right? Super simple example. And this happens 3 times. So we can push one to the GPU. And that GPU can do all the work that it needs to do that drawing. And we can start filling up another command, that's another frame that's going to be pushed to the GPU. So while the GPU is doing something, like processing that and drawing, we can actually ignore what the GPU is doing and continue on with another frame that we're going to fill. And I did 3, and people have been saying, okay, well, 3 is not that necessary. You can do 2. So I'm going to try 2, and hopefully that's going to simplify, or at least change the race condition, right? So if we have this issue where we were reading and writing from the same buffer, it's going to be a different behavior if we change that. So frames in flight has gone down to 2, and instead of having 2 frames, we're going to 3 frames, we're going to have 2. Yo, Shadow. I'm glad you're here. I'm glad everyone's here. Thank you for joining us. Yo, Mado, how you doing, dude? Good to see you as well. So we've just changed things to 2 frames in flight, so I'm not actually sure what's going to render at the moment. Yeah, okay, interesting. Nothing broke, which is fine. The downside of having more frames in flight is you reduce the latency. Sorry, if you have too many frames in flight, the CPU ends up processing so many frames ahead of the GPU, so what you're actually seeing, what the GPU processes, this is what's actually drawn. You end up with some latency, which means you see, I don't know, you want to pick up this blue sphere, but like, let's just say we have a silly amount of frames that we end up processing in advance. We could have like 100 frames in advance. It would take a while for this to be deleted because the GPU would be so far behind our CPU, which we don't want to do. But I'm kind of curious to see what the behavior differences between that is. So now I've explained that. Hi, TT. Enough, I think. Yeah, feel free to ask questions about stuff, by the way. It's always welcome. So I'm going to press 0 and just see if we just get the same behavior. And can we close? Okay, so it looks like we get the same behavior, so that's not to be expected. We could have this race condition still happening. So the next thing I want to try is, it also reduces a lot of like memory overhead. We don't allocate as many Vulkan objects, so yeah, it is positive. First thing I want to try is actually just check this variable isn't used anywhere else, because I don't really like this variable. In fact, I'm going to try and get rid of it because I don't really like the use of it. It's only caused me issues. So yeah, we're trying to do a pop and swap with our memory here. No, I haven't solved the issue yet. So we have, I don't know, I'm in the mood for explaining a little bit more. I'm just in like a, how do I make a new window? No. So a pop and swap, hopefully that's okay, is in a technique where you don't care about the order of an array. Let's go with, no, nope, just, how do I go to outline again? Sorry, I'm not as familiar with nope. I guess we might have to, that's kind of awkward. Oh, fill's down here, right. Okay, no fill, there we go. Okay, no outline. Okay. And we do want an outline. Solid color, maybe? Okay, there we go. Let's make it bigger. Okay, my bad. Okay, so let's just say we have an array, right? Where we go from... We have like a couple of elements in this array. Like this. And this is like how you can visually memorize... visually, you know... It's kind of like this in memory, to be honest. It's pretty similar. This is called contiguous memory, where it's all in one row. And let's just say we have, you know, numbers in here. Like this. I don't know, 6, 8. I'm going to avoid saying that next word. 11, 9, 0, right? And I want to delete 8. Now, what you can do is just delete 8, right? So we can just be like, all right, delete 8. And then what we have to do is then from 8 afterwards, we have to move it over. We have to move 11 over. We have to move 9 over. And we have to move 0. We have to move 0 over. Now, this can be quite slow. This is like an n... if we delete the first element, for example, we'll have to move everything over. So this degrades with size. So if I delete 1, then I have to move 2, I have to move 3, I have to move 6, I have to move 8, I have to move 11, Right, so pop and swap is the idea that we take an element, right? We move it to the end, right? So we move this becomes, swaps these around. So this is why it's called a pop and swap. This becomes a 0, and this becomes a 6. And now, based on the fact that we want to delete 6, it's very easy just to delete the end one. We don't have to remove anything around. Nothing gets moved. That's a pop and swap. So with that, we don't have to do that shuffle that we had to do at the beginning. The downside is now everything's out of order. Now, if you have to be careful with this because the pop and swap is faster. But if it's out of order, if you rely on the array order, so if this is actually really important, so for example, I don't know, say if this 1, 2, 3, 6, 8, 11, 9, 0 means something in that order, pop and swap breaks that order. That completely breaks the order. So that destroys the order of the array. So I'm trying to do that with what I'm doing here with a delete swap. That's basically what we're doing. We're swapping the element 0, or what we selected here is 0, and we move that to the end. So that's the first element in this case. So that element 0 would be here. We move that. We basically do this, but with number 1. And then we delete the last element in the array. So that's a faster delete operation than doing that shuffle operation. So yeah. Now, isn't that just a linked list? Is it better to make a linked list? No, not necessarily. So a linked list is... They're all bad. They're all bad. They're all good in different situations. So a linked list isn't contiguous. Why you would want to use a linked list is so you can do these delete operations easier. Don't get me wrong. The order is preserved because you have a link between the two. So it's almost like if I do this, instead of having arrays, we have like arrows that point backwards and forwards. If a single linked list, we have these arrows. And if I want to get to like element 8, for example, I have to follow, I don't know, let's just go green. I have to follow these like these pointers. That's what they're pointing at, different pieces of memory along this chain. And if you want a doubly linked list, the doubly linked list just means that we have our arrows pointing the opposite way, like this. So if I go from 8, I can go, you know, I want to go from, you know, 3, and then I want to go back to 1. That's a doubly linked list. The problem with this data structure is it's fragmented, meaning that instead of it being like in one big block, like I'm representing here, the memory is all over the place. So it's like 1 is here, 2 is here, 3 is here, and, you know, let's just say 11's here, right? And like we have arrows that go like 2, let's change the color, 2, and then 3, and then 11. You can see like in memory this is going to be more expensive to like look up rather than an array, which is like a straight data structure, contiguous in memory. It goes from top to bottom. So they are good. I don't use them very often, but the general rule of thumb when it comes to programming, again, it's a general rule of thumb, don't follow it exactly, is use arrays until you can't use arrays anymore. Because arrays are always going to be generally a good starting point until you need to know. If you, for example, decide that you want to use a linked list without thinking about it, you might end up with a slower memory access pattern than you need to if you could just get away with doing it with an array. And it's also, you got to be careful with linked lists because they're kind of hard to be thread safe. It's a bit more difficult because these links need to be protected, and when delete something. So it's if you have an array and you can use an array, use an array. What if dedicate one value that represents the deleted stuff or empty array, and then everything stays in order? So what if you dedicate one value that represents deleted stuff or an empty element? I'm not sure what that data structure would be, Matt. It sounds linked arrays then, yeah. I mean, yeah, you can have technically you can have a linked list that contains arrays, and it's not like they have to have numbers. You can do a pop and swap and keep the index array that goes with it. Yeah, it's just the order of the things. That's what I'm trying to explain to people. The order of the array breaks. And if you don't care about the order, then it's actually better to use a delete swap, because you've changed the order when you do a delete swap. But you know that. I assume you know that. I was just explaining it. So we have an array here, which is the data. So I'm talking through this very slowly because I'm trying to wrap my head around a lot of different things. So when you move the last element, you can change the index. It's all good. Yes. Standard Hive is basically a linked list. But that's C++ 26. Okay, so Matt, let's just try and figure out what you said. Let's say we have an array 1, 3, 5, 6. Let's delete number 5, then replace it with -1. Yeah. So you see that, yes, a replacement is not the same as a deletion because the array is the same size. So all you've done there is change a value in the array. So that's actually called constant time. It's actually like, if I have this array, right? We'll get back into it. I have element 9. I want to change it to 7, T7. That's as simple as it gets. Because we haven't changed the size of the array. So anyway, so I'm delete swapping here. Yes, that would be true, and the indexes would be the same, right? But the indices of the so the indices that we index into an array. Okay, so I'm not sure if I explained myself very well, but let's try again. So I'll just do this, right? Let's do. We did this as 0, didn't we? If I do a delete swap. So we have an index, right? We have 0 index, we have 1 index, we have 2 index, we have 3 index. So when I want to access this array and I go, okay, index 1, the value is actually equal to 2. When I do index equals 3, and I do equals 6, very cool, right? This is very straightforward, right? These map to these numbers. Now if I do a delete swap on number 1, this is where the problem breaks, right? So originally we had this as, let's see, let's do 2, right? Wait, I might have got this wrong. Let me. No. Okay, so it matters that the it's contiguous in memory, I think, more than the actual indices of the array. We just don't do the shuffle. That's the only difference. Yeah, it's the same. It's the same. I'm getting confused, but based on that, I think I explained it well enough. We swap these two values. If I want to do a delete swap, we do this. Now this refers to 0, and this refers to a 1, and then we take this and we delete that. So now index 0 refers to 0, but we wanted to delete that anyway. So you have to be aware that it's the same thing. If we deleted this in the other way with the shuffle, we deleted this, and then we had to move this, and this, and this, and this, and this, and this. Yeah, okay. Let's... Okay. Let's see. Okay, so, but if you... which word are we talking about? So, you're talking about Hive? Okay, so, but if you do that... you can keep a free list and reuse the slots and add entities. Is the... Hello, good sir. Thank you for joining us. So if you delete an element... Yep, okay. Yeah. Yeah, so the indices have to change. But yeah, it's like two different delete operations. Hopefully I've explained that. Maybe I didn't explain it very well. Maybe I don't even understand it that well. Is this OPP or FOP? This is DoD? Neither. C++ DoD style. I'm not even sure what FOP even means. So you can educate me on that if you want. Anyway, so let's dig into this, right? So we have an array. I recreate this array. We delete it. I don't flush the array, but this array is like... people were saying earlier that you can't just have one array because you have this buffer swapping thing where you get a race condition, which I explained earlier. So what I'm going to try and do then is just to see if I can actually represent this data with a... for each frame in flight. But I'm not entirely sure if we need to do that. I'm not convinced that having two buffers is actually going to mean anything. Because we have... This is a buffer device address that's basically a shader storage buffer object. But it needs to be updated by the CPU, so maybe I'm messing with it and I've got a data race. So I just don't really know. So all I need to do is swap here. So I've simplified a lot of my code. It's I've commented it out, as you can probably see by the demo. Should have gone for F poop, shake my head. Yeah, I don't know what functional object programming, I don't know. I think you can just do a pop and swap inside a compute shader and not have... Yes, you can do... This is what I was almost on the stream, let me think. At the end of yesterday, on Sunday, I was thinking, oh, do I need to use indirect draw calls and like submit draw calls? That's only going to help with GPU time, GPU calling, GPU changing the buffer on the GPU, which is cool, but we need to update the buffer based on gameplay, which is different. All right, so let's make two buffers instead, right? So this is going to be quite simple. So I have already reduced the frames in flight, as you may be happy with. The only reason I stuck with three frames in flight, by the way, was we're not updating this thing here, was because I was initially tying my frames in flight to the swap chain image count, which is not the same. Yeah. Right, I is equal to so GPU frames in flight, which should be equal to 2. Yeah, okay. So we're going to make 2 of these buffers and just see what the differences are. And now we need these to be... Actually, I'm going to make these statics because... I'm just going to say 2 for these 2. Yes, it's not exactly the best structure, but I want to... These are just structs of numbers, so it's not like there's anything important here. I don't need to initialize the data. Okay, so we have frames in flight, and based on the current frame, which is from the GPU. So the GPU structure is where all my Vulkan code lives. So current frame is what the frame is on, and this will go from 0 to 1. It'll just keep flipping between the two. So 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, etc. So, hang on. Yeah, I don't quite get this because okay, so the first thing I'm going to ignore this deletion code for a minute. Because I don't like this, what we're doing at the moment anyway, so it's kind of confusing, like when do I actually delete a buffer, when do I actually use a buffer? What is different from your attempt at graphics from other people in Vulkan? Isn't it the same thing you are trying to achieve either way? I don't know what other people's goals are, to be honest. I'm just coding because I want to and trying to make a game with it. I don't really have like an outcome of like I just want to become a better engineer, so you know, the outcome of my efforts are irrelevant, honestly, under that. So if other people make, including, you know, AIs or whatever, make a tool that's better than mine, then, you know, cool. Doesn't really change much for me. I'm just going to continue on. So other people have said stuff. You can have a delete entity compute shader. You call when you need to delete an entity. You're trying to change video memory, isn't it? Isn't it in use? That's what I'm trying to do. I'm trying to make 2 different buffers, right? It can lead to nasal demons. Yes, I'm trying to avoid race conditions here, for sure. So this is what I'm demoing at the moment. So we're having 2 different buffers, even though they're buffer device addresses. The pop and swap don't seem to be doing anything, and I have moved everything. So it's important to note that someone has said that... Oop, what am I doing? You're doing something on a GPU buffer on the CPU. This is host visible, so it's... yeah, okay. So this is host visible memory. So according to Rebar and a few other graphics driver stuff, so the GPU should be able to see things changing. Or the CPU should be able to update things on the GPU if it's host visible by write. So let's just see if this breaks, right? So we have 2 different buffers for 2 different frames. Yes, the buffer device addresses technically are the actual pointers. I don't know why that slowed down, interestingly. Okay, so we don't get any validation errors. Now, if I try to delete stuff, it just won't work. So now we have to delete the buffer, or modify the buffer that isn't in use, which is kind of tricky. Because when we delete swap these elements that are host visible, let me read some other things. Even if you use ACS, you need to tell the GPU compute shader. Even if you use a compute shader, you need to tell the GPU which entity you want to delete. Why are you deleting a buffer though? Because the buffer's size has shrunk. I personally have tried AI, paid one's best model. Believe me, it is really bad in game dev. Yeah, I believe you. So yeah, the buffer device, there is a buffer device address pointer, and there's like the actual buffer that lives on memory. So the GPU, if you know how pointers work, all they do is they look at a piece of memory and they tell you where the base address is. So right, I don't think I need Paint for this, but I'll explain it very briefly in Paint. It's not going to be exact. It's not going to take too long. So if I have like a random block of memory, this is again just for people who can follow, and it's just like this. It's like arbitrary, and I want to access this random bit of memory, you know, or whatever's in here. All the pointer is just a arrow, a value that allows me to go. You know, it starts at 0, or usually it's x1 or something, right? So 0x1, it starts here. So that's the pointer to the buffer device address. This is the buffer. We're trying to update this guy. The pointer won't move. We're just trying to change the size. The problem is I'm trying to change the buffer, so I'm trying to like make it one block smaller, like this, right? We're trying to get rid of this guy. Now the problem is this buffer is now smaller, and how I index into this buffer is with an instance variable that indexes through each thing. So it goes, okay, so it goes for this one, that's like 0, goes to this one, and that's 1, and this goes on and on and on and on and on all the way. Now if I've deleted this guy and we're on like, I don't know, let's just say 400, this should be 400, and I'm like, all right, read 400, and it doesn't exist anymore, then we're getting problems. So what I'm trying to do is delete this buffer and recreate it, so we end up having the right size buffer once we've deleted something from the memory. Because the size is different, and we're indexing through an instance. So I'm not entirely sure if this is correct, right? I don't know if we need to recreate the buffer. Don't know. So hopefully that's what I'm trying to do. Hopefully that explains it, and hopefully it explains my understanding of where we're up to, and why people are saying like, oh, if you're modifying a buffer like this thing and the GPU's reading from it, you need to make sure that at the beginning of the frame the CPU and the GPU are paused, so they are in sync with each other briefly, which I'm trying to do this at the beginning of the frame. So this happens just before I don't know when to verify. So this is the new frame, right? This is when we wait on the, I don't know if I should be doing it literally here, like delete here, right? Or should I do it before, or does it have to be close? I don't know when this actually gets synced. Yes, but this is the problem with synchronization right now. So the synchronization issues, there's like a buffer that might need to be updated at a different time. Like I'm doing it just before, but I don't know if I need to do it like immediately after the command. I think is it just record? This doesn't have the command buffer, does it? No, I think does this get executed like instantly? I actually don't know, because that would be an assumption here. So wait for fence, wait for only more fences to become yes. Okay, so does it happen instantly though? If the wait for fence is called, okay, returns immediately, but does it execute immediately? If the condition is not satisfied, the time for wait for fence is called, then wait for fence will block until the condition is satisfied, or the timer has expired, whichever is sooner. Yep. Okay, we can actually test this, right? Now, this returns instantly, but work on the GPU is not always the same. Let's read chat there. GPU. Okay, wait, I have an idea. When you delete an element, you split them into 2 buffers, with the second one starts at the address of the deleted buffer. I think that might be what I'm trying to do is effectively duplicate this. So I don't know, let's do another one, right? So if the CPU is on this one, oops, go white, and so if the CPU is here, it's paint. Sorry, if the GPU is here, right, it's on this one. Then I can mess around with this one, and once we go to this buffer and start reading from it, then we update this one. We delete this bit here, right? And then once we go back again, then they're kind of in sync again. But because this is a CPU GPU, this is on the CPU. This is all on this is GPU, right? This is all GPU, all GPU. The CPU is like, all right, when do I actually access this? When is it safe to access this? When is it safe to access this? It doesn't know. And what I'm trying to do is like pause it at the beginning of the like this. It says wait for the GPU to finish work. So I don't know if it's like okay, now we're safe to do stuff. I think that's true. Safe to do stuff, right? Because we acquire we acquire an image here to actually start to pass over to the GPU. So yeah. So yeah, the GPU is already done. Yes. Okay. Thank you. Aren't you shift? No, I would have to upgrade my motherboard. To go to Windows 11. Don't duplicate the splits. So don't duplicate. Just split up at the deleted element and start the address at address +1. Yeah, what I'm thinking of doing is like deleting the buffer the current frame is on. I don't know which one it is. So let's just assume, right, that because we have 2 frames in flight, that it's going to be either the current frame, which I'm going to say is current frame. If it's not the current frame, then we can do the other frame, which is not the current frame, which we might have to use the previous frame for. So I do have a previous frame variable. So we're going to do this and this and just see when we delete. So this just stops me deleting more than exists. I had to do it kind of funkily. I'll get rid of that spaghettiness in a minute. Well, once it works at least. Okay, so we're going to delete one and then hopefully... No, that's not going to work. That's only going to work once. Okay, so... The problem with this is it's only going to delete one buffer. Let's just see what happens. I'm kind of curious. So be warned, we're probably going to get a validation error. If not, we're probably going to get some horrible graphics flickering, but I doubt it. Yeah, okay, so one buffer is updated and one buffer hasn't been updated. Let's just see the difference, right? So why is there an... What? So in theory, one's correct and one isn't correct, but I don't know. Don't duplicate, just split up the deleted elements and start. So yeah, I just don't quite understand, Mado, what that would mean. Okay, so Casey has said it is pretty slow to create a buffer allocated at once at startup. Use the max. And then it doesn't matter. Let me think. I wonder if I'm overcomplicating this to the nth degree. Like to a degree that's insane, right? Because if we can create the buffer and we just don't care... yes, I do. Welcome back. If we don't, sorry, if we recreate, if we do what the cap has said, we allocate a giant buffer. We then just leave it alone. The only thing we change is the instance index. We don't allocate anything. All right, so yeah, I really want to avoid this deletion of the buffer. I just don't know how to deal with the instance index changing. Okay, so this is the what is happening? Okay. Oh, okay, right. Let's go back. I want to try something. I want to try a different approach. So this double buffer thing I don't really like because I want to try and avoid doing this. Which I'm not too stoked about. So it just seems super. Oops. Like the cap said, it does seem super slow, and I really don't want to do. I really want to. I've been trying to avoid it the entire time. Okay. Okay. Let's scroll down. But yeah, we definitely need to update the position. Right, I'm going to look at my shaders for a minute and just think about what we're going to try and do. Alright. So I'm going to go with my shaders and just kind of talk through what I'm trying to achieve here. So this is the blob buffer. This is this thing, right? This rectangle. And what it stores in it is the position color based on and some padding, right? We ignore that padding. I wonder if I'm already doing this properly and I'm just not. I need to. Oh, I'm in the wrong shader. Sorry. I need to be in this. Nope. This one. Okay, it's basically the same shader. That's why I got confused. So it's the same shader, but it's got the model in as well. Because I was getting a bit confused then. And an instance in this case is one instance of a model. So we have like those rocks that we saw, these spheres. These spheres are instances, which means like we have 1, 2, 3, 4, 5. So this variable is doing things per instance. This is doing something per vertex. Yeah. No, per index of a vertex. And what I'm trying to get around is... I'm just wondering if I've got this correct. Can you explain briefly what this buffer is, how you use it on the GPU? If I understand what it is, I can help you in a better way. Yeah, buffer is just memory. Yes, I can. Yes, so it's just an instance buffer for different transforms and color. It's exactly what it is. Yes, that's exactly what it is. I didn't read your message, but I'm glad you're catching up to speed. So you can ignore. So I have 3 buffer device addresses that operate at different levels. So this is per scene, right? So this operates per frame, I guess would be more accurate, but it's even more than that. It's like per scene. So it's like these are all the things that every single thing has in common, which includes like the view projection matrix, global scale. I'm eventually going to rewrite this so it's not. I think I'm going to separate them off. This is per instance. Oops. So when I'm trying to delete something out of here. This is the thing I'm trying to delete out of. Yeah. Okay. Delete out of here because the position / color of the instance slash entity, because they're the same. Instance and entity. Instance is just the GPU way of saying an entity. In my case, is gone, and this is per index. So each model has indices. I think if you're a graphics programmer, you know what an index means, but just think of indexes of a. I'll just explain this real quick. It'll take like 2 seconds to explain. I know not everyone's this beginner, but I just want to make sure that we're kind of on the same page. So if I have a square, nope. Why do I want to? Nope. Can I rotate this? Go the other way. Alright. I'm just going to try and draw it freehand then, with lines. So everything's made up in triangles. If this is a shape, a vertex would be every single time that we have a... so if we're drawing this triangle, it'll be like 1, 2, 3... And if we're drawing this triangle here, 1, 2, 3, there's a bunch of waste here. We can actually just go, okay, instead of counting the same vertices twice, we go 1, 2, 3, 4, right? And we go to a higher number like this. That's just an index, so that's per index. Hopefully that explains what that means. Yo, congratulations on that. Per instance, per frame, per is a very common. Is called frequency of update. Okay, frequency of update. Fantastic, yeah. Okay, so let's go back to what we're doing, right? So I'm trying to delete per instance, but I'm kind of thinking, right, if I reduce the instances, like how many instances we have, and I'm only deleting this like this. Okay, so it's very trivial for me to just do this, right? I'm going to show you guys something, right? Right, let's get rid of this. I'm starting to question my own, like. So this tells me count of model type. So we have a model type which is like in this we have an index into a model type. These are just spheres. You can think of this as a sphere. And we say like, okay, when I'm creating these, I count how many we have. So for each model type sphere, we increase this by 1. Now, this tells me how many instances we have to draw, so of that model type. Now, when I delete this, I actually just reduce the instance count by 1 because we've deleted that particular instance by 1. My question now is, do I need to worry about any of this? And this is the instance data itself. So if I actually get rid of this, right? And I only just subtract 1. And what this is doing here is this is getting the index of the model type based on the entity value. So entity 0 has model index 70, and that 70 means sphere. And then we subtract 1 from the sphere index type. So when we actually do the drawing, which is here, we loop through all the model types. Or do we? I thought this was model types. Hang on. Is this model types? Yes. Okay, so debug, model, and model, I believe, are the same. Yes. So this is for the debug geometry, which is like the collision geometry. This is for the actual scene geometry. So we loop through all these, right? And then we do an instance draw call based on how many there are, and that's the vertex count of that particular model types. Index count. So in this case, it would be 4 for a square. For ours, it's like 1,000 something because it's like lots of parts of a triangle make up a sphere. So yeah, I'm wondering if I just need to subtract. If I subtract an instance, right? I'm gonna delete the last one from the list. So this is the problem I have, right? So I will reach out in a minute. I promise. So we have, again, an array. This is effectively just an array, right? Of each instance. So Maybe I should have just used the paint tool, but here we are. And this is now red. Okay, I'm just going to ignore that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can count to 11. Fantastic. So when I actually subtract an instance count, I only delete 11. I stop rendering 11. I don't... You know, if you destroyed, say, 4, you actually destroyed 4 here. If I reduce the instance count, which is actually correct because the array should be smaller now. Here, this is smaller. This one's actually deleted from the CPU side. We actually only delete this one, and 4 is still rendered. It lives. Just do a simple compute shader that will move the last instance data into the index of 1 point you want to delete. So a simple compute shader that moves the instance to the end. So if we have, what Hulk is saying is, let me just do this again. So we have this, right? A compute shader does generic compute. So you know what we talked about a delete swap earlier? He is suggesting that we write a GPU program that preemptively does this. It moves this like this, right? And this becomes, let's just change the color. This becomes an 11, and this becomes a 4. And then on the CPU side, we go and delete this. And then 4 is actually deleted. 11 still exists, which is actually what we want to keep. So we actually do the delete swap on the GPU with a compute shader. See you, dude. Good luck with your studies. So is that correct? Just to absolutely clarify, is that what you suggest? Oh, and yes, you use these commands. You use vk copy buffer and vk command copy buffer to these compute shaders. Yeah, I think we're gonna have to do this if we're gonna have to modify something that's already uploaded on the GPU. Now, the question is, for me anyway, how do you actually do the delete swap on a compute shader? Sorry, there's just the swap of the actual memory. So how this works, as far as I remember, is you build up a buffer, you copy it to the compute shader. So you have a, let me do this again. So I want a square. So we have a, let's increase the size again. Oh my goodness, stop changing color. So we have this, I'll explain what these are in a minute. And then we have a, I don't know, this and this. I'll explain with these. So we have a compute shader, which is CS. So we need something before that. So the compute shaders first. Then we want to write to a buffer. That buffer goes to the vertex shader. Vertex shader, I don't know. And then we actually delete the thing here as well. So we have one less in the buffer, so it's like -1, I guess. No, sorry. So swap. We write out the buffer. So this is a write operation. Write, I'm going to put W for write. Then we write out the buffer again into the vertex shader. And we write in the buffer from the GPU. Yeah, I think that's it. The final rectangle, it doesn't make any sense, so ignore that. So these orange are CPU. So this is the original buffer. So B, and then we do an instance minus here. So IN -1, which is what we already do. And we keep writing out this buffer. And in between, we have to do a copy. A VK copy. I can't be bothered right now, but yeah. VK copy over and over and over again each time. Yep. Okay. And to do that, we need barriers and all that fancy stuff. But I think I wish there was a better way of doing this. I wish there's like a non-compute shaded version. That we had to add a second like passing barriers. Yeah, I wish there wasn't. Maybe I am overcomplicated. If someone can tell me like a very simple. Oh, I just want to remove an instance draw called thing from a list. That's it, right? And like I said, I don't know if you guys know the problem, but yeah, I'm trying to. I don't want to say like, I would really, if someone was just like, okay, let me be that someone, right? I'm saying if someone like you guys have to do something, you guys don't have to do anything. I'm kind of getting a bit. It's probably the heat getting to me, to be honest. Okay. I can solve this. Let me think. Obviously, your input is extremely appreciated, obviously. This operation is so simple that you can even do it without a compute shader. Just do simple command buffer cover last element to delete, kind of. You guys are overcomplicating it. When do you update this buffer in your code? I update this buffer in my code. Where is it? Here. I update it every single time. It is a buffer that's updated every single frame because the position data is quite important. The instance drawer is obviously drawn every single instance. I think I know what's happening. Can I just? I think I get the problem now. Let me just. I don't know how to solve it, but I think I know what's happening, right? So when I delete, I think I'm successfully deleting stuff from a buffer device address buffer. I think I'm successfully doing that. However, to update that graphically, all I'm doing is I'm subtracting 1 from this value. The problem with that is that's only going to delete the last element in the list, no matter what I do. And it's going to draw because there's like a missing. Let me blank this all out again. I hope this is not frustrating, but it's a tricky one because it's very tricky. Okay, so I feel like what's happening. Oops. I feel like what's happening here is we are getting a successful deleted thing. I'm going to throw this into render doc, and I think it's going to verify what I'm doing is right. So we have 0, we have 1. These are just the indices, right? This isn't the value. So I think I'm successfully legit. Oops, that's a terrible 7. I feel like I'm successfully deleting the first element, and everything's being updated by a delete swap. It's doing this thing. We've talked about this. This now becomes a 7. I should actually change this to greed. We have done this before, right? 7. This becomes a 0. This gets deleted. We have arrows to do the delete swap. Blah blah blah. Yes, very good. Okay, but the instance index is this is just the position data. I think what's happening is it's the instance index when I -1. Although it's supposed to be deleting this one, this is just the position data. And I believe we're probably getting a gap. I think what ends up happening for the instance draw, as far as I can tell, is this is the position data updated, which seems to be correct. I'm not gonna. I wonder if I can copy and paste. Can you do that in Paint? Yeah. Okay. So it's like there's a gap here. So this becomes like size blur. So it's like this becomes empty. And then it tries to figure out what this is. Oops. It goes, alright, try and render 1. And it goes, question mark? It doesn't know what that is. We won't. It just goes, alright, yeah. That's why I think when I delete an element from this list, let me show you what it looks like. It's so I'm trying to delete the blue sphere, right? And we get some like nonsense happening. So 0 gets deleted, but then it's like I don't know what to do with the first element now. And so I'm just gonna I don't know what it's doing. It's kind of super confused. I think it's picking up something from here. But this is obviously UB, right? This is like undefined behavior. Because we have the same number of instances, but the first element that we're trying to reference here is it just know what it is. That's as far as I can tell. Yeah, I updated every frame, yeah. Because this update, the reason I do that is because it's positional data, right? So it's per instance. So these need to be updated constantly as they're moving. Obviously there'll be other stuff moving as well. W send map 4 to 0. Where is the ducks? I tell you, you cursed it. Yeah, unfortunately the ducks are going to be away for a minute. So let's open this up in render doc and just see what the data is for this data. What I'm looking for in render doc then is, let's try and break this more. Actually, let's do something a bit weird. What I'm going to do is I'm going to delete more than one element from this list at the same time. So I think if I do this, we get a buffer out of bounds read, as far as I can tell. But what I'm going to do is delete 2 different elements. No, okay, so we get the same stupid behavior, and I want to break this more on purpose so render doc has more. We have more data to work with. So let's delete swap +1 +2 +3. So we're going to delete the first 4 elements. We have more than 4, so that should. Okay, so I don't know what happened there, but clearly everything kind of freaked out for a minute. Let's try and delete all of them. Yeah, let's do that. Let's be even weirder. Let's delete the whole scene. Entities, clear. So I'm going to throw this into render doc. So that's going to delete everything. That sets the size to 0. So I'm just going to Alright. So what I believe has happened, right, is I think we've removed all the position data, but it's like, it doesn't know what to draw. It literally has no idea what to do. So hopefully, oops. When we compile this for RenderDoc, we actually see some like gibberish and nonsense in our draw calls. No, I'm not using an ECS. So let's do that. Let's throw this into RenderDoc. Where's the log? Wait, can you see what I mean? If I have a if I go into the vertex shader, if I have an instance blah-de-blah value of, like, say 10, and I delete everything that exists in this buffer, like, what is it doing? It doesn't make any sense anymore what this is. Alright, so no. What am I doing? I'm trying to get up. Yeah, I'm just doing the debug. I'm just because it's the simplest. The only reason I'm doing that is just because it's just the simplest thing. I wanted to simplify the scene right down. So let's. Yeah, okay. So I went into log. I deleted everything in log. Oh, no, I didn't. I just wanted to show you guys that, so you're all on the same page. Let's go to GPU device, and we'll delete stuff off here. Go to release, and I don't think I've changed the shaders, but I will copy them over anyway. Let's see. While that's compiling, it's going to take a minute. I don't manually copy. I only manually automatically copy over the shaders here, but release. All right. Yep. Okay. So does this run? Will it blend? Huh. Interesting. Okay, did I... It's probably missing an R asset, actually. Textures... What is it? Did I not copy over the shaders? I'm just going to do that again, sorry. Let's do the whole folder, it's just easier. Copy, void... Oops. Yeah, that... Assets. Alright, so let's try it again. Huh. Okay, now I've got to turn on logging because I don't know what's going on there. Let's get rid of that. It's just more stuff not to click on. Okay, so this will take me no time at all once this is on. Okay, right. If you remove from here, why is it still the same amount of entities? Are you updating the instance count? No, that's the thing, I'm not updating. But when I update the instance count, I can only, as far as I can tell, subtract 1. But if I subtract 1, the cap, I'm only it seems like, from my point of view, I'm only removing this. It deals with this one when I delete it, and then if I remove 2, it deletes this one. Even though I've removed this guy over here, it only ever deals with like the last one in the list. So why is BRV obsolete? Is it? Okay, so that's the what's the issue? Could not load. Oh, it's audio. I forgot. Sorry. Completely forgot I've updated all the audio. It is still, even though we're not using it, it's still loading the audio. Right, yeah, okay, so simple mistake. Okay, so one last compile. For release. Okay, so this shouldn't be a massive thing. Yeah, that's the thing. So how do I update the instance count? Okay, so let's do what let's update the instance count, which is easy enough to do, and I'll show you the thing that I do not understand. So in this case, the instance count should be 0 because we're not drawing anything. So this should work. Sorry, it should like this, right? I know we're in release, but everything's gone. Very good. I'm moving backwards, nothing's there. Okay, cool. That works. However, I delete element 0. I subtract 1. Now, just for, I know you think this is a constant value in this subscript operator. There's only one element in these two at the moment anyway. Well, for debug model, which is the one we're using. There's only one sphere model, there isn't any others. The size of this is 1. I subtract 1 because we've deleted one thing from the elements. And if I... Oops, sorry. Now, pay it. Let's do a screenshot because this took me ages to get right. So I'm going to do this because it's easier to notice the difference. I press 0. Now, you see what's happened? It's deleted the blue and the last. It's deleted this guy and this guy. That is the thing I do not understand. You see they're both missing? And what ends up happening is if I was to run this again, or maybe you can see it, no. If I was to run this again and delete it quickly, you'll see that when it was moving, blue gets deleted and a yellow one gets left behind. So what I think is happening is it's trying to figure out what should be here for the instance draw call, and it's only deleting this one from the actual draw. So we end up getting this situation where this gets deleted and this gets deleted, but the instance draw call is still trying to draw this guy, which we deleted in the actual buffer, and it doesn't know what to do. So it picks up some random data from like here, which I believe is this is the yellow one. This would be yellow. This is blue. So it picks up like the yellows data. Okay, so let me catch up with chat. But hopefully I've explained kind of what's happening. Maybe you guys have already said what I need to do, and I will read. The chat's gone a bit quicker today, which is cool. So the instance count. Yep, okay, so that's where we draw. I heard it from Google. If it compiles to GLSL, it is obsolete. SPOV is incredibly verbose. Yeah, that's fine. It's not obsolete. You're a live entity, I guess. So 10 being rendered. Yes. Yes. Boom, boom, boom. Can you check the pop and swap code? Sure. I could do that. It's extremely verbose. Debug it. External tools. Oh, you mean GLSL is verbose? Yeah, I can see that GLSL is verbose. Let me continue the music for a minute. No, not that. Not that. I don't know why it stopped. Someone said yesterday that they don't get any problems with their YouTube playlists, but I do. I don't know. Maybe YouTube has a personal vendetta. Alright, so let's just cool. Alright. Okay, so let's look at the pop and swap, right? So if the size, so we have index that comes in, so this is the index we're trying to delete. We assert that size is not equal to 0, and we have to make sure that size index is less than size, so these both have to be true. This is an invariant we can't have. All we do is we take the last element in the list, which is, oh, we don't actually delete anything, do we? We just move something to the last element. Is this what I was supposed to do? Hang on, hang on. Hang on. Hang on. Hang on, hang on, hang on. We might not be doing the pop. I might. Maybe it's because I use. Okay, so we got a. Okay, let's move back to debug. And something crashed, and I don't know what happened. Oh, hang on. No, wait. Go back. No, I think I was fine. I think I was fine, actually. I think I was fine. This is tricky. This is a tricky thing. So this is... Okay, so this is C++ being a pain in the neck a bit. Okay, so when you do a subscript operator like this, it's very important. There is a difference. Okay, so this is actually fine. This is actually reducing the size by 1. However, when you do the when you do this unary, when you do this operator first, it returns the value, and then it subtracts by 1, rather than subtracting by 1 first, and returning the value. That's how the operator works. So you can actually do this, and it is the equivalent of. Oh no, this is fine. This is fine. This is actually. But I will, for sanity's sake, just do it like this, right? We'll just do it like this because. Yeah, be very careful with the differences. There's a difference between these two. Okay, so let's do that again. Yes, the last element is -1. Because that reduces the size of the array, as far as I can tell. I wonder if it actually deletes something from it. Did that? Hang on, what? That usually makes a second. Let me do that again. No, okay, there we go. I thought it did. Are we even Now I'm a bit worried now because it feels like we're not deleting something from the array. Because we have a chunk of memory that we're allocating. All I'm doing is I'm removing an element and I'm reducing the size of the array by... This might be a... Hang on. This might be to do with my array structure. This whole thing. Not in the ways you guys are thinking of. I've had this problem where... It's not a buffer overflow. It's... Where is it? It's my bad. Skipping this. Nope. This data here is just a pointer, and I'm just kind of nervous now that have we actually... When we do this pop and swap, what... Are we operating on data? Yes, we are. Okay, so we're operating on data, and then we reduce the size of... And when we get... last limit -1, right, though? You're swapping the data size. Yes, I think I am. Yeah, okay. Let me think. No, I think I'm starting to... You know, when you're starting to see problems that don't exist. I think this is what... Yeah, I think we need to move on from this. This has worked in other situations. This is fine, I think. As far as I can tell, I think what I'm doing is... Ah, right. Yes, I see what you're doing there, Cap. Yes, you're right. Actually, that is a mistake. Thank you for pointing that out. You are right. It has to be -1. That is correct. There we go. Yes, because that's... Yes. This doesn't make any sense. I'll be overriding the buffer, though. Yes, thank you for that. Ironically, that was an overbow buffer, but yeah. Okay, so unfortunately, that's still doing exactly the same thing. Why is that there? Yeah, I see what you're saying now. All right. Let me think. So that has had different behavior, and the instance count. Maybe before a screenshot and render doc, inspect the buffer data. Yeah, I think I need to. Yeah. Okay, so let's compile this for release and turn off the debugging, which I think I already have here, but let me think. So yeah, let's get render doc. Let's get render doc open. Right. Alright. Launch application. Release. So, oh, okay, so it's picked up the wrong model for some reason. Okay, let me just fix that. That's pretty easy to fix. I just don't want the data to be different. So just a quick... Yeah, that wasn't an error or anything. That was just me using a different model. Like a bad model. Okay. So... Release. Okay. Let's do this. Launch application. Delete. And... Now I've got to do a bit faster than that. Let's try again. Alright, cool. That's what I want to see. And capture frame immediately. And let's have a look. Right, okay, so what do we need to look at? We need to look at these. Index draw call. We have 9 instances, which is true. We have 10 initially. Index count. Right, what do we have? We have a barrier, which is probably just the regular stuff for a frame. And right, so we have this and rendering. Okay, so it's very simple. Now we need to see the mesh viewer, I think. Now, how do I want to do this? Because there's multiple instances, and I want to just see one instance. Because that's going to do... Yeah, that's so... let me think. So we need to see this buffer, actually. That's more important. The buffer is in... Where would that be? That would be in the... It would be in one of these. And... Okay. So that links back to itself, it looks like. We have the device, we have memory. And... Device 10. Right, what would this be? Alright, so we need... So this is all the same memory with different buffers. Where is the... What would be... Is there a way to see what this is? Like what are we looking at here? Okay, so this is the... What's this one? So this has to it tied. We have 1, 2, 3, 4, 5, 6, 7. 7 buffers. And then nothing, as far as I can tell. Okay, so all the buffers are tied to this memory. We have semaphores, obviously not these, not the swap chain, not the device, not the pool, the baked. Okay, so no. Okay, so it's got to be one of these guys, but I actually want to see what's in it. Do we have a name that we can see anything? Buffer, P allocator. Okay, so let's investigate. Bind buffer. Yeah, there's nothing in there. So create buffer. So what is this? This is a Storage. Usage. Okay. It's exclusive. Everything's exclusive. I don't remember setting that flag. Let's just try a different one, see if it's like more obvious when there's another one. Oh, we could probably find it by size actually. That might be a really useful. Yeah, because the sizes are all going to be unique. Hopefully RenderDoc hasn't made a mistake here, because this is going to be impossible to find otherwise. Okay, so let's figure out the size at runtime. So we're going to have to go back to debug and just figure out the size of the buffers that we care about, which is the positional buffer. I wonder if I can actually... Yeah, check the size. I think you're right there. Let's It's funny, like sometimes I'm not looking at the chat and it feels like I've like someone in the chat says something and it's like, oh, okay. That's just what I thought as well. I swear I'm not peeking over. And then being like, aha, I'm so smart. I figured it out too. Yeah, okay, so let's do that as well. Before we do, so pipeline. Ah, okay. This might be vertex shader. See if they okay. So we have a push constants. What's this then? No, stride 2 wouldn't make sense. It is a line list, that is correct. Okay, so it's found the... It's decompiled the shader. What's this? Oh. That's what we're looking at. Yeah, they're the shader modules. I assume that's the first one. No, okay. Let's try again. I'll exhaust everything here and then we'll look by size. Okay, so yeah, there's the push constants. Alright. It is possible that is true with the buffer device address not being supported in RenderDoc. I'm not sure. Let's we actually just care about this one. So I'm just gonna see what the size of this guy is. But it's possible that the size is not real. So in debug, we got everything activated again. It'll take a minute to compile. Yeah, I had a feeling the music. No, okay, it's working and oh, breakpoint. Okay, so 1,600. Okay, that's gonna be easy to find. Let's go back in RenderDoc. Or easy to remember. Let's say not necessarily easy to find. So resource. So it's not that one, and it's definitely not that one. Nope. 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 Okay, so it's this guy. We found him. Now we need to investigate the actual... Weirdly, this should be a little bit smaller now I think about it. We've already deleted something from it, right? Or is that just not how it works? I feel like I need to go into a cave for like 6 months to study the esoteric parts of Vulkan memory to figure out this. It just seems so convoluted. Like, surely you have an instance renderer, right? And you delete something from the instance renderer. Let's just say element 2 out of 0 to 4. And then that gets removed from the scene. Like, that can't be that complicated to do. Despite the fact that I'm using buffer device addresses here. Because at the end of the day, that's all I'm really doing. Let's have a look. I'm just going to assume that it's nothing to do with that. Just for a minute. To assume that... Because it's just too easy. So there's the count. First instance. Yeah, because all I'm doing is just removing like a middle instance. How do I know which one's which? It's not frustration. It's more like this has to be simple, right? I think I was actually more frustrated yesterday. It just doesn't make sense. Like, why is this so complicated for this particular issue? Even if we ignore, right? Because here's what I'm thinking, right? If we ignore this buffer device address that's updating the position and all that stuff, right? Forget that for a minute, and we can actually just get rid of this for a minute. I want to delete the blue sphere in this scene. It's the first element. Now I can actually remove the first element, but I can't remove like the yellow one. Like, how do I remove this if we have like an instanced drawn thing? So this is done in one draw call. Now all I want to do is get rid of like the yellow, but it gets rid of the last one like every single time, no matter what I do. Like, let's just forget the buffer device address. This is as simple as it gets. How do we arbitrarily delete something from an instance draw call? Okay, so that's the problem I'm going to try and solve for the rest of the stream, I think. So let's just do a bit of Googling. Removing an instanced draw call object from the scene, from a scene, right? And then we'll try and narrow it down from based on that. Because I think what Hazel had done, Hazel does this different. I believe, as far as I can tell, every single frame it counts how many elements are in the list of. So Hazel is a game engine that was developed by the Churner on YouTube. So what that did is it took each rectangle that you were drawing and it counted how many it did, made a buffer at draw time, and then drew. If I deleted something, let's just say I deleted, it's yeah, okay, that's not what I want to do. This, okay, so pretend there's 5 like there wasn't. So if I want to delete this, the buffer is actually created every single frame. And then that's what gets instance drawn. because it counts how many times you've ran a function called draw quad. It goes 1, 2, 3, 4, 5, etc. And then it goes, oh, alright, you've got 20 instances this time with this particular buffer. Draw that. Right? Now, the instance draw calls have to operate over a buffer, otherwise it doesn't make sense. That's not how instances work. You can't... Yeah. I just need to operate... Yeah, that's what I'm thinking, right? Let me puzzle, because this is not that complicated, what I'm trying to do. I think I've just overcomplicated it. Because literally, if I get up this code, I'll show you what I mean. I think I had this running yesterday. Not running, just nope. That's the wrong. Okay, I'm just gonna have to go into here. So this is the Hazel game engine, and I'm going to go into 2D renderer. Oh, I'm already here. So it counts these draw quads. Sorry, it creates like a struct with data in them, which is static. It counts. This is an instance, right? So it counts how many of these we have, and at the end, before we start drawing, this is OpenGL, by the way. It's not a Vulkan. It does, I believe, where is it? I think it's either end scene or begin. It's one of these. Oh no, okay, so it's not that one. It's the end scene. So it does it sets some data up. And this actually, oops. So this creates a buffer based on, I think it actually creates a vertex buffer. But anyway, it's using the base pointer minus this pointer. Gets the size, which I'm sure. And then flush, what does flush do? Oh, it's here. Yeah, okay, so here's what I was looking for, actually. So there's the actual instance draw. So if I go in here, and index count, as far as... I believe, is for my OpenGL knowledge is really weak, but... Is this doing an instance draw? I actually don't know. Anyway, so it's basically building stuff up, even if it's not doing exactly what I think it is. It's still building up like a list of things to draw. Then it draws them, and it creates it every single frame. It's still creating a buffer every single frame. Like it's still doing that every single frame. Now, granted, the Hazel/Tempest engine isn't the best. There is a lot of like issues when it comes to like the architectural implementation. But if we have an instance draw call, right, it needs to operate over an instance of things based on a positional data, whatever. So as far as I can tell, we need to subtract one from this, that's a given. And we need to, it feels like I just need to write to the buffer again, but let me just look at something. So what is the thing we're writing to? So the size, we remove one element from this array. Okay, so that's one thing we need to do, which we weren't doing earlier. So if I remove this with a delete swap, and we remove one element from the array, we get probably the same result, I'm not going to lie. Oh, press the wrong key.